and gentlemen, we have Dubravko Hlede, which is the CIO, the IT manager for a company named Rimac. Rimac or Rimac?
Rimac.
Rimac. Rimac Automobili. And it's a very nice surprise for you guys, because Rimac Automobili is a company founded in 2009 with headquarters in Croatia. They started as a garage project like Microsoft, and they grew into a globally recognized technology leader with over 600 employees. Rimac Automobili is a technology powerhouse, manufacturing electric hypercars and providing full tech solutions to global automotive manufacturers. Rimac Automobili has challenged the status quo with a vision to revolutionize and reinvent the sports cars. With its unique technology and with the support of Dell Technologies unstructured data solutions. So guys, we have Dubravko Hlede here, which is very popular from Rimac. Dubravko, you have the floor.
Thank you for introducing me. So I'm Dubravko from Rimac. I will give you a glimpse how we develop our autonomous driving in our cars. What is the idea behind it and how we do it and what are the challenges. So when we are handling AI data, that is almost unlimited because of the growth of data, the needed data to develop such a product. We are also trying to learn the car how to drive, how to use the available power, the steering, the condition, the everything, so you can enjoy actually owning a car that can go 400 kilometers per hour or even more. So what is our main product? This is our main product, our C2 hypercar. It goes from 0 to 100 kilometers per hour in less than 1.85 seconds. It has almost 2,000 horsepower. The torque can be compared with heavy semi-trucks. It will just blast you like more faster than any jet plane that you ever flown it. But this is not the only thing that we do. So as a company, we developed in the last 10 years to not only be an electric hypercar company. We developed expertise to develop components for other manufacturers, battery packs, battery management, infotainments, drivetrain, powertrains, electronics for the car, autonomous driving assistant, and connectivity. Any of our products is IoT device. So everything that you buy from us will have its own telemetry. It has their own internet connection. So everything today, all the hype technologies, all the gadgets we implement, we use and give as a full product to any company in the world. One of our customers, let's say, it's not only Porsche Group, it's or VW. We have Koenigsegg, Jaguar, Bentley, you name it, we got it. All the companies, the major car companies in the world, especially in Europe, are dealing with us in one way or the other. So the main topic of this presentation is what we are doing to assist everybody to have an advanced driver assistance system. It's actually autonomous driving. Maybe you are aware, maybe you are not, but there are actually 5 levels of autonomous driving. First level is you have a cruise control. Cruise control is with us at least for now 20, 30 years. It will just maintain the constant speed that you have. Now, most of the cars, especially in the higher price range, they have lane assist emergency brakes. That means that's a level 2. It will take limited control from the driver. It will assist him. It's still an assist system. It's not autonomous at any level. It will have emergency brake. It will change. It will keep the lane. You won't be able to go from one lane to another. Level 3 is driving in less complex situation like highways, but no pedestrians. So level 3, it's something that is in dispute right now all over the world because many car companies actually proclaim they have a level 3, but they have only certain features of level 3. So there's a lot of work to be done to have complete level 3 autonomous driving. Also, and then level 4, driving automation in limited areas. So if the area is well known, everybody knows about, you map the area, you know all things that can happen on certain area, then you can say you have a level 4. That's autonomous driving. We have certain companies developing that for, let's say, big airports or some suburban parts of the big cities, but it's very limited. If you want to use the same system on any part of the globe, anywhere else, you actually need to rework your entire algorithms from the scratch. And of course, level 5 is full driving automation, no steering wheel whatsoever. When we will reach it, as you can see, there are a couple of projections, but it will happen eventually. But tremendous pressure on infrastructure and AI and machine learning, that's continuously postponing that. It will happen, but as we develop such a system, we encounter more and more obstacles, challenges, but they're constantly being solved, but it takes a lot of time to solve them. So right now, the, let's say, optimistic approach says we will have autonomous driving level 5 somewhere late 2030s, something like that. And I will try to explain you why that is, okay? So Professor Wiener from Darmstadt, he's a well-known mathematician, said if you want to have level 5 autonomous system, you need to record more than 210 millions of kilometers of real driving to validate your algorithm. When you take those 210 million of kilometers and multiply that with 9 cameras, 5 radars, 4 lidars, ultrasonic sensors, telemetry units, gather all that data, it takes you to astonishing numbers. So each car during the development gathers 3 terabytes of data each hour. That's when you use only full HD resolution on the cameras and only 30 frames per second. That's very, very important because everything goes from those numbers. And you say, okay, we need to drive 210 millions of kilometers at average speed of 60 kilometers. That makes 3.5 million hours of driving. And remember those 210 millions, because when you multiply everything there, you need to collect more than 10 exabytes of data. As you can see, you have kilobytes, megabytes, gigabytes, terabytes, petabytes that we are dealing right now, and we need to achieve exabytes. Exabyte is more than 1,000 petabytes. But that's not all, because these numbers that I'm showing you are last year. It's something that we estimated last year. Now, in the last 12 months, we realized that the resolution, the frame per second that we need to gather is relatively small, because we are trying to develop a coaching system that will enable you to drive a hypercar. To drive a hypercar 400 kilometers per hour. Not everybody can drive that, because you need to be very skilled. You need to have experience. Actually, you need to own the car that can go that much. But what does our system will do? It will coach you, it will guide you in the process how to make a car drive 400 kilometers per hour without crashing yourself. So let's go back to the data that we collect. So we have the estimate that I showed you of 10 exabytes of data to develop a level 5 hypercar driving. That was an estimate of 12 months ago. Now we have increased the resolution of the cameras to 4K. We increased the frames per second. We realistically, we concurred that average speed of driving is actually 30 kilometers per hour. Okay, you drive 200 or 300 kilometers per hour on the racetrack, but when you are in traffic jam, when you are waiting for a stoplight, when you are searching for a parking, average speed of the car is 30 kilometers per hour. When you multiply all those numbers, you come to an astonishing number of data that's 80 terabytes or more. Now, zettabytes that come after exabytes start becoming more and more realistic, something that you can even picture that you're using. Exabyte is something that nobody used a couple of years ago. Now we are talking about zettabytes, and there is yettabytes after zettabyte even. So what we do with the data? So problem, it's not only acquiring data, it's problem how to manipulate data, how to transfer data, and how to enrich data. All the data that we gather from the cars, we put on using this cloud station on our central storage. Storage is based on Dell Open 1FS system, Isilons, and in that process we enrich data. So what cameras, leaders, etc., they give you a glimpse of what the videos contain, but you need to enrich them in saying, okay, there's a rain here, there's a fog here, there's a pedestrian, this is a stop sign. Your algorithm will learn more and more from that, but you need to control those metadata to make it reliable, so the machine learning and AI algorithms that will adapt the algorithm how to drive a car will learn and be more reliable in the future. For that, we are using NVIDIA DGX clusters and we constantly increased the supercomputers power each and every month. We are talking about something that was never even considered realistic in a couple of years ago. We are talking about petaflops, petaflops, exaflops of processing power that will happen in next couple of years. And now even the private companies such as Rimac are heavily investing in supercomputing power. So what is involved behind that? Behind that, we have infrastructure that must be very elastic. It can grow in a matter of months, even years, from 0 to hundreds of petabytes, because the goal is in exabytes. We need to keep that data up to 15 years. There are regulations in automotive industry saying you need to keep the data for 15 years to prove that your algorithm was based on reliable data. So there's no cold data there, because if you said to an algorithm, let's learn how to make a left turn, you're using all the data that has a left turn in it. So there's no cold backup. There's no put it on the tape and forget about it. Also, if you have a dispute in the future, you must make data available in 72 hours in case of an incident. You have write once, read many protection. So your storage need to have, your policy needs to handle that. It needs to be future-proof. Can you imagine having a storage of tens of petabytes and your manager says, okay, let's migrate that to another system? It will take years to migrate, not weeks, not months, years. You need to have high-performance computing clusters with GPUs, with tensor processing units. The faster, the better. Just put everything you got in it, because the data is tremendous. So you need to invest in supercomputing power. Any network, the higher bandwidth, the better. The latency in supercomputing, only InfiniBand can challenge that. We upgraded from on 10 gigabyte interfaces in our core network 3 years ago. Last year, 2 years ago, we upgraded to 40 gigabyte interfaces. Now, all our supercomputers and core systems are working on 100 gigabytes of network. So any network speed that we can get, we use it, because just to be able to move the data in a relatively short period of time. So when you have such a system that has such a large amount of data, there's no possibility of downtime, because there's no possibility of restore. Yes, you have backups, you can restore, but you cannot restore the full restore because it will take you years. So you need to design the data, the system that will never fail. Hopefully will never fail. You need to have redundancy, multi-sites, replication, everything. Safety to data is everything. You cannot lose any data, because if you lose any data during the 15 years retention period, you cannot validate that your algorithm was right in case of any incident. So this is, I gave you the brief overview what is needed to develop such a system. Hopefully, we don't have a lot of time here, but hopefully you got a glimpse how we work at Rimac Automobili.
Thank you very much, Dubravko. Absolutely brilliant presentation. And honestly, we have to allocate for for this topic at least a workshop for 1 hour and a half or something. And I guess I will discuss with Del to have that in front of the CIO Council members. So honestly, I think this is the first time when I realize for good what means to have a good infrastructure, and what means to have an infrastructure that will never fail. Yeah. Now I'm risking a question. All this infrastructure is on-prem, is that correct?
Yes, all that infrastructure on-prem, because of the scale of the data, and that we don't have a cold data. Any cloud provider is just too expensive. It's actually more worth it to have it on-site than in cloud. And we are talking with all the major cloud vendors.
Yeah, well, basically, because the question was, it's obvious that for the majority of the businesses, migration to cloud, it's a solution, in particular in these times. But yeah. For your company, I'm not sure it's the right time right now, at least right now.
In this case, for example, we are actually using cloud resources for supercomputing when we need one-off supercomputing. So we are transferring the part of the data, but to store the data, we still believe that the best value is to store it on-prem for 15 years, because nobody can pay any cloud provider for 15 years to store exabytes of data.
In how much time did you restore a data in case of a dispute, from 2 years ago?
At this point, we can do it more instantly, but because right now we are working tens of petabytes. But when we come to the level of 100 petabyte or more, we will see how it goes, because even the storage that we use is constantly evolving. Why we chose Dell? Because it can work in same cluster. Nodes can work even when they are 2 generations apart, and 2 generations are 5 to 6 years, let's say. So we can make a hybrid system of old systems and new system, and constantly migrate the data behind it without any user interaction, and users do not feel any problems accessing the data during those times.
Dubravko, I would have many other questions, but we have to stop right now. Definitely we have to arrange a separate session for CIO Council members. Thank you very much. Hvala ti lepo. Thank you very much.
Thank you.
And we'll stay in touch, and we will come back with our next speaker. Thank you.
Thank you. Bye.